Hi, boys and girls. Welcome to 6-1 Solving One-Step Inequalities, the No Word Problem edition. I want to get this done in a couple of days, and we can't possibly get that done if we're doing word problems. So we've axed those from this section, and we'll play around with word problems in 6-2. All right, so it starts on page 341 of your workbook, Solving One-Step Inequalities. I know you guys covered this last year, so I think this will be review. We're going to do it a little bit differently than we do most of our units. So just pay attention, and I'll tell you what to do. Graphing inequalities. Okay, graphing a solution set. All right, they've given you the equation y is less than or equal to 4. Okay, when you graph that, let me just explain it to you my way. Get my pen going. All right. If you have greater than or less than, you're going to use an open circle. Why do you use an open circle to graph it? Because whatever number this is, like say if this is 7, I'm going to tell you that the solution set is greater than 7 or less than 7. But these mean that 7 is not part of the solution set. Now, if you have less than or equal to or greater than or equal to, then that means that 7 is included in the solution set, and we used a colored in dot, okay? So if the or equal to is present, the dot is solid. If the or equal to is not present, that means that that number is not part of the solution set, and the dot is open, just in case you've forgotten. The dot is at 4 shows that 4 is a solution, because this is y is less than or equal to 4, so y might be 4. Okay, that's why it's colored in, and then you shade the numbers that are less than 4. Okay, the heavy arrow pointing to the left shows the solution set includes all numbers less than 4. Okay, so if you're going to graph the solution set, y is greater than 1/2. Okay, first of all, we have to find 1/2. 1/2 is going to be right here. Is it an open or closed circle? It's an open circle because there's no or equal to. We only know that y is values more than 1/2, but not 1/2. So where are the values more than 1/2? They're to the right. Now, some kids quickly figure out that whatever way this little guy's pointing, that's the way you shade. Notice up here, it's pointing to the left, you shade to the left. Pointing to the right, you shade to the right. And that will work half of the time, because it only works if your variable's on the left and the numbers are on the right, okay? If the variable happens to be on the right, that little rule doesn't work, okay? So be careful and make sure that you're reading the problem the way it's meant to be graphed. Okay, then you will be given a graph and you have to write the inequality, okay? It says the endpoint shown with a circle at 1.4. So 1.4 is the, I don't know what you would say, cutoff in the solution. I don't know. Is not included, is what they want you to write. Not included in the solution. The inequality must be greater than or less than. Okay, so have they given us the letter that they want us to use? I don't see that they've asked for a letter. Okay, so we're going to go with X then, I guess. The arrow points to values less than 1.4. The graph represents the solution of X is less than 1.4. Okay. Over here, write an inequality that represents the graph. Notice this is colored in, so this is an or equal to, and it's going to be greater than. So we're going to have X is greater than or equal to, and the dot is on -10, so -10. Like I said, I think this is all probably just a review for you guys. Solving equalities using addition and subtraction. This is done just like solving equations. You can add or subtract to both sides of the equation or the inequality as long as you do it fairly, okay? Now, they are introducing what they call set builder notation, okay? This is how they want you to write your solution to these. They want you to do the fancy brackets with the X and then this long line, I think it's called a pike. And then you write the inequality or whatever, like X is less than 7 or something. And then you do the other dealy bobber like that. So that's how they want the answers written. For your practice page, I'm just going to have you turn that in handwriting. And I'm not going to be picky about that. If you turned it in with X is less than 7, I'm going to be perfectly cool with that. Okay. Solve inequalities by adding. All right, so here we have a simple one-step inequality. All right, you want to get x by itself, so you want to add 10 to both sides. They're doing this linearly, and I'm not a fan of that. We normally do ours like this. We would have x minus 10 is less than 15, and we would put the plus 10 underneath. And I know that's how the high school does it too. And then you would have x is less than 25, okay? So x is less than 25. The solution set is, and this is where your set builder notation comes in, x is less than 25, and then they've already drawn the parenthesis thing, okay? So that's what that would look like. I just want you to be aware of that in case you come across a multiple choice one or something and you're not sure what it looks like. Okay, here we want to get b by itself, so we want to get rid of this minus 9 or negative 9. So we add 9 to both sides of the equation. We get b is less than or equal to 25. So b is less than or equal to 25. Easy peasy. Okay, you're just adding and subtracting to both sides of the inequality to get the variable by itself. Alrighty, here we have, and now we have one where we're going to have to subtract. We have x plus 24. What's the opposite of plus 24? Minus 24. So we subtract 24 from both sides. What is 61 minus 24? If I do it in my head, I'll screw it up. But I'm old school. I was taught to borrow and carry, so I could totally pull this off. 37. So the solution set is x with the big long line thingy, and x is greater than or equal to 37. But on the written work, you could just have that. Write the solution set for this. Well, we need to subtract 13 from both sides. And that gives us 75 is less than x. I like to have my variable on the left-hand side, so I would flip this over. But notice when I flipped it over, I kept the inequality saying the same thing. I flipped the inequality also. Here, x was greater than 75. Here, x is greater than 75. So especially if they're going to do it in set builder notation, then the x should come first. Yeah, like so. Okay. So far, so good. Add or subtract to solve inequalities with variables on both sides, okay? I'm going to do this over here because I hate all this fill in the blank crap they give us. All righty, so we have variables on both sides. We need to target the smaller one if at all possible, which is this 9y. So we're going to subtract 9y from both sides. That gives us 3 is greater than or equal to y. I'm going to flip a roux, so y is less than or equal to 3, all right? So y, long line, y is less than or equal to 3. And then they want us to do this one. You would subtract 7x from both sides. These are total setups because they haven't taught you to do multiplying and dividing both sides yet. So these are set up to where you end up with a variable with a coefficient of 1. 6 is less than x, or x is greater than 6. Set builder notation, x, line, x is greater than 6. Now, they didn't really cover graphing too much, so here's what I would do. I would just go ahead and put a 6 here, and I want to show x is greater than 6, so I have an open circle, and I shade the numbers that would be greater than 6. That. We're not doing the word problems, so ignore example 6. Wow, that is a lot of print to put on a page of a math book. That's almost terrifying. They want you to know the properties. Oh, no, I'm not going there. Let me tell you this in its simple words, okay? For example, let's say we have a true inequality. Let's say we have 7 is greater than 2. 7 is greater than 2, right? That's true. If I add 2 to both sides, then I have 9 is greater than 4. Still true, right? If I have 7 is greater than 2, and I subtract 2 from both sides, I get 5 is greater than 3. Still true. But what happens if I have 7 is greater than 2, and I multiply both sides by negative 2? In inequalities, that's perfectly legit. But with in equations, that's perfectly legit. Inequalities, watch what happens. Negative 2 times 7 is negative 14, and 2 times negative 2 is negative 4. But negative 14 is not greater than negative 4. All right, so they have a rule that says if you multiply and likewise divide both sides by a negative number, you have to flip the sign. Let's divide both sides by a negative number. How about if I have 10 is greater than 2? If I divide both sides by negative 2, then I would have negative 5 is greater than negative 1. Also not true. So that's what that whole page of words was meant to tell you. If you multiply or divide both sides by a negative, you have to flip the sign. But you can add or subtract to both sides and you don't have to change the sign. Okay? And that's a word problem, so we're not going there. Also a word problem. Okay, so now we're to solving inequalities by multiplying. Notice the coefficient of x is a negative number. In order to get rid of that, we're going to have to divide both sides by, oh, they want you to multiply both sides by the multiplicative inverse. Okay, well, anyway, negative 2/5 x is less than or equal to 11. All right, basically, you're going to divide both sides by negative 2/5. Really, that's the same as multiplying both sides by negative 5/2. Okay, so we would go x is less than or equal to 11 times negative 5/2. All right, that would be 1. And we would get, now here's the thing. Do you see this? This has got to be changed. Hang on a second. Picture day question. Okay, so here's the thing though. When you multiply or divide both sides by a negative number, remember, we have to flip the sign. So I should have already gone ahead and flipped the sign. I was focusing in on this multiplication of fractions over here, got all excited. So, you know, I love to multiply fractions. So we get x is greater than or equal to negative 55/2, which apparently they want us to change to an actual number. Well, 54 divided by 2 would be 27. So x is greater than or equal to negative 27 1/2. So where is negative 27 1/2? It would be right here. We have an or equal to, so we're going to color in the dot. And we want to show that x is greater than that number, so we're going to shade to the right. That. So if you wanted to write the solution set, you would write x with the long line, and then x is greater than or equal to negative 27 1/2. Now we're going to divide both sides. Okay, so we have 20x is less than 4. Well, what do we have to do to get x by itself? We divide both sides by 20. Now, do we flip the sign? No, because we're dividing by a positive number. So flipping the sign is not an issue here. Okay, we divide each side by 20, and this would be 1/5. They want me to graph that? How am I supposed to graph that? That's a dumb graph line. Okay, so x is less than 1/5. The solution set is x. X is less than 1/5. Where the heck is 1/5? Well, probably maybe like about here. Oh, and it's got to be an open circle because it has no or equal to. So not only do we have to try to estimate where 1/5 is, we have to do it with an open circle. And x is less than 1/5, so we're going to shade to the left. That was a stupid number line. Oh my gosh. Hang on again. People will not leave me alone today. Oh my gosh. Oh man, I'm going to have to divide. I'm going to need a calculator. All right, calculator. Okay, so here we have a inequality where we're going to have to divide both sides by 7 to get x by itself. Well, I don't happen to know what 161 divided by 7 is. You would think I would, right? You'd think I'd have my 7s memorized that high. I do not. And I divided both sides by a positive number, so I don't have to flip the sign. X is greater than negative 23. Just because this number is negative does not mean you have to flip the sign. You only flip the sign if you are multiplying or dividing by a negative number, and we're not. So don't flip it. Now, you could write it in set builder notation. X is greater than negative 23. If you want to graph it, you can graph it. I've just put 23 here. Open circle. What numbers are greater than 23? The ones over here. There you go. Do-it-yourself graph. Okay, solving an inequality with the negative coefficient. I'm still going to need the calculator. Okay. So here we have negative 13z is greater than or equal to 117. We divide both sides by negative 13, but when we do that, notice we flip the sign, okay? So we flip the sign, and 117 divided by 13, I don't have my 13s memorized either, is 9, negative 9, okay? So z is less than or equal to negative 9. So negative 9 would be here. It's less than or equal to, so it's a solid dot. And the less than side is over here, like that. Okay, super fun. All right, select the solution set for, oh, this one I know. Negative 13x is greater than negative 169. Okay, we're going to divide both sides by negative 13. But when we multiply or divide both sides by a negative number, we flip the sign. So we will have x is less than, and this will be positive 13, right? So the solution set would look like this. And which one of these is it? Looking for positive 13 where x is less than it. It would be B. There we go. That's what I'm talking about. And that brings us to the end, okay? So you're going to want to do the page in your workbook for this section, okay? Do the page in your workbook for this section. Here they want you to graph the solution set for each equality, all right? Just go ahead and draw me a line next to the problem or on a notebook paper, stick the number on it, and then draw the graph. X is less than or equal to, colored in dot, numbers that are less than, I'm going to shade this way. Okay, just basically do that for those. Do all 6 of these. Do 1 through 6. That's easy. Here, write an inequality that represents each graph. Okay, go ahead and use X or first initial or whatever. Okay, so this would be X is less than negative 1. All right, this would be X is greater than negative 6. You see what I'm doing? If they're colored in, remember to put the or equal to. Okay. Do all of those too. So right now you're doing 1 through 12 for sure. This is just too much, just too much. On these, on 13 through 30, just do the evens. 13 through 30 even. And you don't have to graph them, just write the answer, and you don't have to write it in set builder notation. So do all 1 through 12 all, and 13 through 30 evens on your workbook page, and you will turn in the workbook page to me in person. Don't put your cooties on it. No. Okay, so you have to have a secret word, and I completely didn't have anything planned here. So we're going to go with Mrs. Williamson used her blue calculator for this lesson. Okay, so remember I used a blue calculator. That is your secret word. Okay? Well, I hope you had fun doing math on paper. Turn it in your next in-person class, and I will see you there.